3, 2, 1.
MDS
We have ignition. We have a liftoff.
On September 5th, 1977, humanity launched a message in a bottle into the cosmic ocean. An object made of metal, gold, and circuits, weighing just over 700 kilograms, was hurled away from Earth on a one-way trajectory. Today, nearly 5 decades later, the Voyager 1 and Voyager 2 probes continue their silent journey. They are the most distant human-made objects from Earth. But for the vast majority of people, the story of these probes ends the moment they stop working. Before we embark on this timeline that stretches far beyond human history, if you are fascinated by the mysteries of the deep cosmos and want to support, make sure to subscribe to the channel and turn on notifications. Join us as we explore the infinite together. There is a popular belief that the moment the last nuclear battery dies and the final radio signal is sent, the Voyager mission will be over. But this is a fundamental mistake. The truth is much deeper and, in a way, haunting. The end of communication is not the end of the voyage. It is merely the beginning of the true Odyssey. When their electronic voices fall silent, the Voyagers will cease to be scientific machines and become silent monuments of human existence, wandering the cosmos long after their creators have disappeared. In this video, we are not going to look at the past of these probes. We are not going to talk about Jupiter or Saturn. We are going to trace the future route. We will calculate where they will be in 40,000 years, 200,000 years, and even 1 billion years from now. What happens to a human ship when it is left entirely alone in the eternal darkness between the stars? To understand the future, we first need to understand the precariousness of the present. The Voyagers are dying, not from mechanical failure, but from energy starvation. They are powered by radioisotope thermoelectric generators, or RTGs. Basically, spheres of plutonium-238 that generate heat as they radioactively decay, converting that heat into electricity. But physics is relentless. Plutonium has a half-life. With each passing year, the generators produce about 4 watts less power. NASA has performed the work of a surgeon, shutting down heaters and scientific instruments one by one, trying to stretch the probe's lifespan. But the math is inevitable. Around the 2030s, there won't be enough power even to keep the transmitter on. The probes will go cold. The temperature will drop to near absolute zero. The silence will be total. And it is at that moment, when Earth stops hearing the faint beep from deep space, that they will enter the ghost ship phase. The first thing we need to correct is the idea that they have already left the solar system. Yes, headlines say they have entered interstellar space. Voyager 1 crossed the heliopause in 2012 and Voyager 2 in 2018. But the heliopause is just the boundary of the solar wind, the magnetic bubble created by our sun. In terms of gravity, they have barely left the backyard. To truly leave the solar system, they need to escape the Oort Cloud, a gigantic sphere of comets and icy debris that envelops our stellar system. The Oort Cloud is so distant that the Voyagers will take about 300 years just to reach its inner edge. And after that, they will take 30,000 years to cross it completely. Think about that for a second. The entire history of human civilization, from cave paintings to artificial intelligence, spans less than 15,000 years. The Voyagers will spend double that time just silently navigating through the comet graveyard that surrounds our sun. During these millennia, they will be completely alone. The chance of them colliding with anything is statistically null. Space is, above all, empty. They won't crash into asteroids like in science fiction movies. They will just float, mute projectiles traveling at about 38,000 miles per hour, perfectly preserved by the vacuum. With no air to cause friction, no oxygen to cause rust, they will remain almost identical to the day they were launched, except for the damage caused by tiny impacts of cosmic dust. But the universe is dynamic, and the stars move, and this is where we reach the great milestone of our title, the 40,000 years. Although the Voyagers were not aimed at any specific star, after all, the original goal was only to visit the gas planets, the laws of Newton and Kepler continue to guide their paths. Astronomers have managed to trace the destiny lines of these probes through the shifting star map. Let's start with Voyager 1, the faster and more distant one. 40,000 years from now, it will no longer be in complete solitude. It will pass relatively close to a star called Gliese 445. Gliese 445 is not a star like our Sun. It is a red dwarf, located in the constellation of Camelopardalis, the giraffe. It is small, cold, and glows with a faint reddish light. The interesting thing is that Voyager 1 isn't going to it. The star is coming toward us. It is a meeting of two travelers on the galactic highway. When we say close in astronomical terms, we need to adjust our expectations. Voyager 1 will pass about 1.6 light years from this star. To us humans, this seems like an infinite distance. It's trillions of kilometers. But on the galactic scale, it's a near miss. If there were someone orbiting a planet around Gliese 445, and if they had extremely powerful telescopes, they could theoretically see a small metal speck crossing their system. But Voyager 1 will be dead. It won't send photos of this red dwarf. It will just pass by, indifferent, and continue its path toward the center of the Milky Way. Meanwhile, Voyager 2 follows a different road. Remember, it was sent on a trajectory below the plane of the solar system after visiting Neptune. 40,000 years from now, it will have its own stellar encounter. It will pass about 1.7 light years from the star Ross 248. Ross 248 is another red dwarf, located in the constellation of Andromeda. But there is a fascinating curiosity about this encounter. The star Ross 248 is a fast nomad. In approximately 33,000 years, it will become the closest star to our Sun, stealing the title that today belongs to Proxima Centauri. For a brief cosmic period, Voyager 2 will be visiting our nearest neighbor, precisely at the moment it passes through our neighborhood. After these 40,000-year encounters, the probes will plunge back into deep darkness. Time will lose human meaning. Centuries will become irrelevant. We will begin to count time in geological eras. 296,000 years from now, Voyager 2 will have another encounter, this time much grander. It will pass about 4 light years from Sirius. Sirius is not a faint red dwarf. It is the brightest star in our night sky, a blazing blue-white beacon, actually a binary system with a white dwarf companion. Imagine the scene: a small Earth metal probe, built by human hands in the 1970s, bathed in the intense light of the brightest star in the solar neighborhood, almost 300,000 years in the future. By then, humanity on Earth may have evolved into something unrecognizable, or may have disappeared completely. Continents on Earth will have shifted position. The climate will be different. But Voyager 2 will still be there, intact, fulfilling a mission that no one is monitoring anymore. And what is the final destination? Where do they go after Sirius? Will they leave the galaxy? The answer is no. The speed of the Voyagers is impressive by human standards. They are faster than a rifle bullet, but they do not have enough speed to escape the Milky Way's gravity. They are destined to become permanent citizens of our galaxy. They will enter a gigantic orbit around the galactic center. Just as the Earth orbits the Sun, the Voyagers will orbit the supermassive black hole at the heart of the Milky Way. But the scale is incomprehensible. One full orbit, a galactic year, takes about 225 to 250 million years. The Voyagers will become artificial metal comets. They will pass through spiral arms, cross clouds of interstellar gas, survive the birth and death of new stars. 4 or 5 billion years from now, when our own sun begins to die, swelling to become a red giant and swallowing the Earth, the Voyagers will still be out there. Perhaps, in that unimaginably distant future, they will be the only proof that we ever existed. And that brings us to the most precious cargo they carry. Fixed to the fuselage of each probe, there is a copper disc plated with gold, the Golden Record, a time capsule designed to outlast Earth itself. The cover of the record contains instructions written in universal scientific language, using the hyperfine transition of hydrogen as a decoding key, explaining how to play the record and, more importantly, where it came from. There is a map using the position of 14 pulsars, which triangulates the exact location of our sun at the time of launch. Some scientists, like Stephen Hawking, warned that sending a map to our home could be dangerous. If there are hostile civilizations out there, we have just handed over our address. But the reality of space distances makes this risk minimal. The true purpose of the record is not to be an invitation, it is to be a testament. The record contains sounds of rain, thunder, whale songs, a mother's heartbeat, and the sound of a kiss. It contains greetings in 55 languages, from ancient Sumerian to Portuguese. It contains music by Bach, Beethoven, Chuck Berry, and traditional chants from indigenous peoples. It contains 115 images encoded in analog signals, showing our anatomy, our architecture, our food, and our way of caring for one another. In the vacuum of space, erosion is incredibly slow. The main threat to the record is micrometeoroids, grains of dust traveling at high speeds that, over eons, act like cosmic sandpaper. Studies estimate that the Golden Record will remain readable for at least 1 billion years, maybe even 5 billion. This creates a melancholic and beautiful paradox. It is very likely that the lifespan of the Golden Record is longer than the lifespan of planet Earth. 1 billion years from now, plate tectonics will have erased any trace of our cities. The mountains we know will have been ground down to sand. The sun, brighter now, will have boiled the oceans away. Any encyclopedia, any hard drive, any stone monument we built will have vanished. But out there, in the deep cold between the arms of the Milky Way, Voyager will still be holding that golden disc. The grooves of the record will still contain Mozart's music. They will still contain the recording of the brainwaves of Anne Druyan, the project's creative director, who recorded her thoughts as she pondered love and the wonder of being alive. These electric thoughts will be frozen in gold, orbiting the center of the galaxy in absolute silence. If, by a statistical miracle, some alien intelligence finds one of the Voyagers millions of years from now, they won't find a threat. They will find a primitive machine, but one built with extreme care. And if they manage to decipher the record, they won't hear war cries or hate speeches. They will hear a species trying desperately to show its best side. They will hear that on a pale blue dot orbiting an ordinary yellow star, There were creatures who felt, who loved music, and who had the audacity to want to touch the stars. The Voyagers are our immortal ambassadors. They are the guarantee that even if humanity fails, even if we destroy ourselves or are destroyed by natural catastrophes, we will not be completely forgotten by the universe. Our music will keep playing, potential and latent, waiting for someone with the right needle to bring it back to life. So, when you read the news that NASA has turned off the last instrument on Voyager, do not feel sadness. Do not think of it as a death. Think of it as the moment they finally graduate, the moment they cease to be NASA probes and become artifacts of the Milky Way. The mission of planetary exploration is over. The mission of preserving human memory will last forever. 40,000 years from now, as it passes Gliese 445, Voyager 1 will be just beginning its walk, and we, through it, will be traveling together, eternally suspended in the great cosmic night.